we will be discussing on the topic bias stability. So what is biasing and what is stability? So what is a biasing circuit? So this is the topic we are going to discuss today. So as we know, the common emitter amplifier circuit, the output characteristics is given by a graph which is drawn between the output voltage VCE and the output current IC for the constant value of IB. So this is the output characteristics curve of an for constant value of IB. This is called as the output characteristics curve of a common emitter amplifier. So normally this graph is divided into three regions. One is called as cutoff region, saturation, and our area of interest, which is called as the active region. When we design a common emitter amplifier, we need the transistor to be operating in this active region. So active region is a linear region in which the output will be varying linearly with respect to the input parameters. So whenever a transistor is acting as an amplifier, the transistor should be only in this region. So we have to make the transistor circuit to be in this region. So for this we need a circuit, and that circuit is called as a biasing circuit. So this is about the biasing. So the next one is what is meaning of stability. So we know that the transistor parameters usually vary with the temperatures. So the three important parameters which vary with the temperature is ICO, beta and VBE. ICO is nothing but the reverse saturation current of the transistor. Beta is the current gain and VBE is the input voltage. That is the voltage which is between the base and the emitter terminal of the transistor. So the ICO, it varies for it increases for every 10 degree rise in the temperature. It doubles for every 10 degree rise in the temperature, and beta also varies, and VBE will be increasing at a certain rate due to the change in the temperature. So when these three parameters varies, what happens to the operating point? So operating point is nothing but a point which is present inside the active region, and the operating point should be always inside the active region. For example, we assume that here we have a point which is called as the operating point or Q point. So this point is nothing but VCE, Q and ICQ. So this point is called as the operating point. So we know that a transistor to have a distortionless output, so the Q point should be fixed at the center of the graph. But we have an equation, the current equation, which is given as IC is equal to beta IB plus beta plus 1 into ICO. So in this case, we have two varying parameters, which is nothing but beta as well as ICO. As I have told, the ICO and beta varies with temperature. Even though we fix our Q point initially at this certain point, due to the variation in the temperature, the beta varies and ICO varies. As beta and ICO varies, obviously my IC varies. So if IC varies, the Q point will be shifted either upside or it will be coming down. So due to this variation, my Q point will make the transistor to go to the saturation region or to the cutoff region. So this causes the instability in the transistor. So what is a biasing circuit? Biasing circuit is fixing a Q point, and stability is nothing but invariant or insensitivity to the variation in the temperature. So these factors should be considered when we design a transistor circuits. So for this, we have various types of biasing circuit. The first biasing circuit we will be discussing is fixed bias. Second one is collector to base bias. Emitter feedback bias. And the fourth one is voltage divider bias. So these biasing circuits are nothing but the combination of some resistors which will make the circuit to be always in the active region. So before going for the biasing circuit, we will understand a term called as stability factor. So what is stability factor? So stability factor is given by S is equal to DIC divided by DICO. So DIC by DICO. What is this? DIC by DCO indicates that the variation of the collector current with respect to the ICO. That is, ICO is nothing but the reverse current, reverse saturation current. So how much does my IC and ICO are varying with respect to the temperature? So this gives the stability factor. So for a good transistor circuit, the stability factor should be minimum. So this stability factor will be varying for the different biasing circuit, and we will be deriving the value, what is the equation for S, and for different value of, for the different biasing circuit, what are the S value we will be having, that we will be discussing now. So we will see how to find the stability factor S. So S is given by DIC divided by DICO, which is nothing but the variation of the IC with respect to the ICO. ICO varies with temperature. Because of the variation of temperature, ICO varies. Because of ICO variation, IC varies. So this variation should be minimized. To understand it, we will have the stability factor S. So we know the equation IC is equal to beta IB plus beta plus 1 into ICO. Differentiate this equation with respect to IC. So DIC divided by DIC is equal to beta into DIB by DIC plus beta plus 1 into DICO divided by DIC. Simplifying this expression and finding out the value of S, we will be having S is equal to 1 plus beta divided by 1 minus beta into DIB divided by DIC. So here we can see that by controlling the base current, we can improve the stability of the circuit. So normally this value should be minimum. It means that the variation of the temperature is compensated by means of the biasing circuits. So we have to find out the various, for the various biasing circuit, what will be the value of S. So along with S, we have two more stability factor which is given as S dash and S double dash, which indicate the variation of IC with respect to VBE and beta value. So we in this topic we will be discussing about the variation of IC with respect to ICO, that is S alone we will be considering. Consider a simple circuit which consists of only two resistors. This circuit is called as fixed bias circuit. So as I have told you, biasing is nothing but connecting the resistors in some form to make or to fix the Q point. So if this is the circuit given, so what will be the S value? So we have to analyze what is S, or we have to find out what is S in this case. So here we can write down the equation here for the input side. This voltage is taken as VBE. So VCC is equal to, so if this current is taken as IB and this current is taken as IC, so VCC is equal to IBRB plus VBE. On the output side, VCC is equal to ICRC plus this voltage, we call it as VCE. Okay, so S is given as S is equal to 1 plus beta divided by 1 minus beta into DIB by DIC. So here I want to find out what is the value of DIB by DIC. So differentiate this equation with respect to IC. So differentiating 1 with respect to IC, we get, so VCC is a constant, so 0 is equal to, we will be getting it as IB into DIB divided by DIC plus VB is a constant value, so we will be getting 0. So we can say that in this condition DIB is independent, or I can say that DIB divided by DIC is equal to 0, which indicates that IB and IC are independent. So here substituting this DIB by DIC in this equation, I will be getting S is equal to, S will be equal to for a fixed bias circuit, substituting this DIB by DIC is equal to 0, we will be getting S is equal to 1 plus beta divided by 1 minus 0, which is nothing but 1. So we will be getting it as beta plus 1. So we can come to a conclusion that S is equal to beta plus 1 for a fixed bias circuit. That is, beta is nothing but the current gain of the amplifier, and it will be around 100 normally. So the S value will be around 100, which is very high, and it means that the fixed bias circuit stability factor is poor. So in order to overcome it, we can go for the remaining types of biasing circuit. So that we will be discussing in the next section. Thank you.